Okay, we are back. We're talking today, this is part 2 of what we started before. We're talking about um, diffusion and osmosis and how things pass through the cell membrane, diffusion and osmosis. So in the part 1 of the video, we had a quick definition for diffusion. Diffusion is the movement of particles from an area of high concentration to low concentration through a cell membrane. And osmosis is the diffusion of water, specifically water, through a cell membrane from its lowest to its highest concentration. Okay, so from the low to high concentration. So they're kind of opposite in that way, and I'll make that a little bit clear later on. All right. There's actually a third process. The third process is called facilitated diffusion. And facilitated diffusion is when certain molecules need a little bit of help to diffuse through the cell membrane. Now, we're going to look at that one a little bit later. And for now, we're just going to look at a couple of animations. These are all really good ones. I've used them for a long, long time. Hopefully they load up. Okay, cannot go. Let's try this one. So you can check out the links on the PowerPoint yourself. This one here is actually not too bad. If you scroll down to the side, I hope I'm still sharing my screen with you. Pretty sure I am. Maybe I am not. Hold on a second. Okay, hold on. Sorry, kids. 1 second. Oh yeah. Okay. No wonder. Hold on a second. Share screen. If you go to the PowerPoint, you're going to see the links that I have on there. And if you scroll down to these links, you go to this one, the second one. It should open up for you. I hope. It opened up for me. It'll take you to this web page here. So when you go to this web page and you scroll down the side, you see that there's some different animations. This one here is a good one. We're going to start with this one, how diffusion works. And it is blocking Flash. Adobe Flash Player is blocked. Okay, so try those on your own, I guess. I guess that's not going to work on my computer. Anyways, let's do a couple of diagrams then. This is just like being in class, right? Because you know what, it's kind of like, you know, things happen and you gotta, you know, adapt to things and go with the flow. So we're going to start off with a beaker. Okay, so figure 1 is diffusion. And through that beaker, we're going to have right down the middle, we're going to draw this dotted line. And the dotted line is going to represent a semi-permeable membrane. We have a beaker, and we're going to show our water level here. So we have a solvent, and in this case, it is water. So I mentioned the learning goals to you earlier. One of the learning goals was, of course, to get the definitions and the comparisons between diffusion and osmosis. This learning goal is to be able to apply them to actual situations. So right now, we're going to put in some of these molecules, and I'm going to call them shaded circle molecules floating around. Now, it doesn't matter what they are. We're going to call them, and we're going to put one on this side because sometimes that happens. And we're going to say something about these. Number one, we're going to say that this molecule, we're going to call it A, is permeable to the membrane. So all that means is that this particular molecule, now in the real world, it could be something like sodium or maybe potassium or something like that. That molecule is actually able to pass through the membrane. That's what permeable means. So there's a key word for you. When we say it's permeable to a membrane, that means it is allowed to pass through. Now on this side, when we start, there's a high concentration of this molecule A. I'm just going to call it the shaded circles. Now, what will happen? What will happen? Now, since A is permeable, allowed to pass through this membrane, and there's a high concentration of it here, what would be our prediction? What would we predict will happen? Which is, again, one of your learning goals. Now remember, in nature, everything wants to achieve equilibrium. It's just a principle in science. It's the way things are designed. Our prediction then would be that these molecules will begin to pass through the cell membrane through diffusion. So molecule A, these guys, will pass through from high concentration to low concentration. By the process of diffusion, So that's basically what we would see happening if it were really happening with a cell and its environment. So this happens with single-celled organisms as well as cells in other living things that are multicellular. So there's a little diagram of diffusion. Go back and look at the animations, please, because the animations will really help you to understand. Now, we do need to look at a second situation. So let's say that we have, make sure this is visible, turned properly. Let's say we have a beaker again. Give myself a little more room this time with the beaker. You know, there used to be a character on the Muppets, and his name was Beaker. The character on the Muppets known as Beaker. And he was kind of like a lab assistant, kind of a crazy looking guy. Same sort of thing. This time, let's say we have a different molecule floating around. So again, we have a selectively permeable membrane. And the solute we're going to draw is going to be a different solute this time. We're just going to call it solute B. Solute B is non-permeable to the membrane. So all that means is that it is not going to be allowed to pass through here. It's not going to be allowed to pass through for whatever reason. Maybe it's too big and the pores in the membrane are too small. So on this side, there's a high concentration of molecule B, we'll call it, the triangular shaped ones. Well, what's going to happen? Remember, these molecules want to achieve equilibrium. They want to be able to balance out. Clearly, there's a low concentration of them here and a high concentration of them here. What's our prediction? Now, some of you are probably thinking, well, the same thing's going to happen. They're going to go this way. They're going to fill up all this space, and they're going to balance out. They're going to balance out. No, that is not what's going to happen, because this solute B is maybe too big. It's not permeable. It's not allowed to pass through. So something else has to happen. And that something else involves equilibrium being achieved through different means, which I will show you. So here's our semi-permeable membrane. And in order to balance this out, what will happen is water will move from the area of low concentration to high concentration to try to, I'm going to draw a couple more in here. On this side has low concentration. Water will move from the area of low concentration to high concentration over on this side in order to achieve equilibrium. It's kind of like when you want your iced tea to be consistent. And if you have, there's only two ways to make two different jugs of iced tea consistent. Either you put the same amount of water in one or the same amount of solute in the other. And there's two ways to balance out the concentration. Play with the solute or play with the solvent. That's the only way. Well, this is osmosis. So figure 2 today is osmosis. And the thing that happened here is water moves from the area of low solute B concentration to high. Low solute B concentration to high concentration. Okay, so there's a little lesson that goes along with today. I got to stop this recording now. If I don't stop it now, it will be too long to load up on YouTube, and then I'm going to be in trouble. So we will do part 3 next time. All right, so follow the assignment and everything should work out really well. Goodbye.